All right, probability, guys. We've all heard and talked about probability. You guys hear probability all the time. What's the probability of this happening? Lots of times I wish I was a weatherman because it doesn't even matter if you're right or wrong. They're like, it's going to pour today. It doesn't rain at all. Then they're like, 100% chance of rain. Beautiful day. Happens that way. But probability is the likelihood of an event occurring. Excuse me. I want you to really focus on the stuff that I'm talking about. You have to think when you're talking about probability, all right? We're going to talk about events, sample space, that sort of thing. In this first question, it says find the sample space. So that means like what are all the possible outcomes? Letter A says that 2 coins are tossed, right? 2 coins are tossed, yes? What do you want to happen? That's what probability is. What is the probability that both, excuse me, both land heads up? What do you want the coins to do? Land how? On heads. Heads up. So probability, I want you guys to write this down. This is super important. Probability is what you want over the total. All right, I'm going to say that a lot. Probability is what you want over the total. Now, probability can be written as a simplified fraction, a decimal, or a percent. Right? 1/2 as a decimal would be 0.5, right? As a percent would be 50%. All of those things are the same thing. So you have to understand how the question's being asked, what they're asking, and how they want their answer. Does that make sense? Okay, so let's look at letter A. Letter A says 2 coins are tossed. So how many coins do I have? 2. I have 2 coins. I have a coin here and a coin here, right? Agreed? All right. What's the possibility on the coin number 1? A heads or a what? Okay. In coin number 2, what's the possibilities? A heads or a? Everybody agree? So if I was going to find my sample space, that means all the possibilities. So I could get a heads and a heads, right? I could get a heads and a tail. I could get a tail and a heads. And I could get a what? Tail and a tail. You guys agree with me? That's my sample space. Those are all the things that could happen. When they say sample space, that just means, hey, what could happen? Now, what did I tell you that probability was? What over what? What did I just tell you right here? Want over total. That is the most basic way that I can explain that to you. It's want over total. So think about this, guys. The question said, what's the probability that they both land on heads? So what do I want? Double heads, right? I want them both to be heads. And how many total outcomes are there?
4.
There's 4 possibilities or 4 outcomes. So what are the chances? What's the probability that I get a double heads? Well, out of those 4 possibilities, how many of them are a heads?
1.
So your probability of that event happening is 1 out of 4. Could you guys have figured that out in your head?
Yeah.
Yes, and I understand that. I'm just showing you mathematically using the words, the event of something happened. The sample space is all the possibilities, but it's 1 out of 4. If I asked you, okay, what is this as a percentage? You would tell me it's what percent? 25%. What is it as a decimal? There you go. Okay. All right, the second thing is a card is drawn at random from a standard deck of playing cards. What's the probability that it's an ace? Well, there's some things, guys, called common knowledge. All right. Does anybody know how many cards are in a deck? There's 52, not including the Joker. Good. There's 52 cards. Now, if you don't know that, excuse me, that's okay. On Canvas and their modules, I will put up like a deck of cards so you can see how many aces, how many spades, how many red, how many black, that sort of thing. But there's 52 cards. Anybody know how many aces there are? 4. Okay, there's 4 aces in a deck. So remember what probability is. It's want over total, right? Well, what do I want to happen? What's the probability that it's an ace? So what do I want? An ace, right? I want an ace out of 52 cards. So 4 out of 52. Do I leave my answer like that? I need a simplified fraction. What does that give me? 1 over 13. Good. 13. 1 over 13. If I asked you for a percentage, you would divide 1 divided by 13 with the decimal place over 2. Questions? We all right? Guys at home, you okay? Wait, did I skip one? All right, not on my notes.
No.
Just skip it. I took it out.
Yeah.
Pleasure talking to you all. Pleasure. Okay. Oh my gosh. Word problem. We got a map. Ay. What do we do here, guys? It says the numbers of colleges. The number of colleges in.
There's a third one.
Say it again.
I think there's a third one.
This year, so that's why. I mean, I have it on my notes here, but just skip 3. Let's go to 4. Random selection. All right. It says the number of colleges and universities in various regions of the United States, 2008, blah, blah, blah. Institutions selected at random. What's the probability that the institution is in one of the 3 southern regions? Remind me again, guys. What is probability? Want over total. Okay. So what do I want? What does it say? What's the question say I want?
The institution being in the southern region.
Okay, so I want southern region over, what's probability? Want over total. How do you guys think I would find out how many students are in the southern region? You would add. Do you guys see the southern region that they're talking about? Do you guys see the word south? Okay, so what do you think you would do with those numbers? You'd add them. So you have 406 plus 286, right? Plus 754. That's anything in the southern region. And then what would you do to find the total? You'd add them all up. So let's not skip any. Let me write it down. 581 plus what? 304 plus 453 plus 668. Does it matter what order you add these in? No. So if you guys write them down differently than I do, just make sure you get them all written down. 630, 754, 286, and 406. Did I get them all? All right. For the interest of time, I'll add this for you guys. It's 1446 over 4347. All right, there's my answer. But what do I have to make sure of? I have to make sure it's what? Simplified. All right. Can I divide this by 2? No. Can I divide it by 5? Can I divide it by 10? How would I check if I could divide by 3? What's the rule for 3? Add up the digits. What's 1 plus 4 plus 9? Just kidding. What? Sorry. What's 4 plus 5? 9 plus 6.
15.
Okay, so the top is 15. What's 4 plus 3?
7.
Plus 4?
11.
Plus 7?
18.
18. Does 15 and 18 divide by 3?
Yes.
That means that 3 goes into these. So guys, what's 1446 divided by 3? Where's my calculator? You guys get 482 over
Oh, wait, no.
4347, 14, 49. All right, what if I said to you, well, guys, that's great and all, but I want this as a percent. How would you find that out?
Divide.
Okay, so what's 482 divided by 1449?
0.38.
0.3326, all right? Well, what is that as a percentage? 33 what? 0.2%. You just do it to the nearest. But if you can remember, excuse me, I'm sorry. If you can remember that probability is what you want over the total, probability is easy. Figure out how many possible outcomes there are, what your sample space is, and then figure out what you want, and you just put what you want over the total. That's literally, but you got to pay attention. Words like at least, at most, neither, something like that. You got to pay attention to those things. All right, now we're going to talk about something right here, the probability of two events. We're going to talk about two kinds of events. One is called mutually exclusive. Let's write this down. Well, this is mutually exclusive here. And don't worry about these mutually exclusive, and this is called overlapping. All right, sometimes you could liken this to dating. If you are mutually exclusive with someone, you have nothing to do with anyone else, right? If you are overlapping, then you got your business all over the place. Everybody understand that? If you have an overlapping event, you're going to find the probability of two events and then subtract the overlapping part. I'll show you what I mean by that in a second. Mutually exclusive events, one has nothing to do with the other one. The outcome is not dependent upon something else. Overlapping, it means that the event of something happening can occur in two instances at the same time. I'll show you what I mean by that in a second. Happens a lot with decks of cards. Right, in example 5, it says, one card is selected at random from a deck of 52. What is the probability that the card is either a heart or a face card? Now, here's where words are going to be really important. I want you to write this down. The word and the word or. And means to multiply in math. And or, means to add. All right, so I'm just going to rewrite in my own little words here what this question says. It's the probability that a card is a heart. So probability of a heart. Or, what I tell you word or means? Add the probability of a face card. Now let's think about this. Is this event mutually exclusive? Does one have anything to do with the other, or are they overlapping? Think about a deck of cards, guys. If I said to you the probability of a 3 or a jack, in a deck of cards, is there a card that has a 3 and a jack on it at the same time? No, those are mutually exclusive. But think about a heart and a face card. Is there a card in a deck that has both a heart that is a face card? Yes. So this is an overlapping event. This is where you have to subtract the overlapping part. How many hearts are there in a deck? Anybody know? Nobody knows? There's 13 hearts. All right, does anybody know how many face cards there are? There's 12 face cards. There's 4 kings, right? 4 queens, 4 jacks. And then I have the probability, guys, that this card could be what? A face card that is a heart. How many of those? What? How many face cards are in a deck? 12, right? There's a king, queen, and a jack, right? So there's at least one king that has a heart. There's a queen that has a heart. There's a jack that has a heart, correct? Everybody see this diagram that I drew out for you. You have to ask yourself the question at the beginning. When they said a face card, that's a heart, you have to say, is there a card in the deck that has both of those qualities? And it does, so you have to subtract it. So how many hearts do I have out of a whole deck of cards? No, how many hearts do I have out of a whole deck of cards? 13 out of how many? 52. Good. How many face cards do I have? 12 out of how many? Good. And of those face cards, how many also have a heart on them? 3 out of how many? 52. All right. The more you do these cards, I promise you, the easier they'll get. You'll see this with suits, like diamonds, clubs, spades, and you'll see it with colors, like a red king or a red face card, that sort of thing, because that event can happen. That's overlapping. There are cards in the deck that are both red and have a face card. So we work this out, guys. What's 13 plus 12 minus 3? 22 out of 52. Simplify that fraction, please. Divide by 2, guys. 11 out of 26. All right, if I was going to change that into a decimal, what would it be? Do it in your calculator. I'm just going to show you all three. What's 11 divided by 20? Sorry. Yeah, 26. 0.42. All right. And then what is that going to give me as a percent? 42%. So you have to determine if the event is mutually exclusive or overlapping. This happens all the time with cards, and we're going to do more of these, I promise. We're going to go through your whole web assignment on Wednesday in class just to make sure you guys understand.
Ms. Meadows?
What's up? All right, look at this example. Go to 6. These are easy. These are super easy, guys. Human resource department of a company has compiled data and the numbers of blah, 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 right? Here's a chart. First of all, probability is whatever what? Want over total. So, guys, what do you think you should do first when you have a question like this? Find the what? Find the total. It'd be easiest to do. How do you find the total of these employees? You add them all up. When I add all these up, I get 529, just to save us some time. All right, there's 529 total employees. So the first question says that has 4 or fewer years of service. They're telling you where to look. My years of service are right here. So what's the only number of employees that I care about if I went 4 or fewer years service? The top one, 0 to 4, right? A wants, I'm going to say 4 or less, right? 4 or less years over the total. Well, how many employees in this company have 4 or less years? Perfect. 157 over the total of 529. Give me that as a decimal. .2967, something like that. Excuse me. What would that be as a percent then? About 30%. Okay, easy enough. Look at the next question. 9 or fewer years. So B wants 9 or less over the total. Well, in this case, where am I looking? The first two. So I would take 157, good, plus 89, and I would put it over 529. 246 over 529, right? As a decimal, that's going to give me 0.4652. So give me that as a percent. It's about how much? About 47%. I agree. What about if they said like between 10 years service and 39 years service? What would you do? Between 10 years service and 39 years service, what would you do? You just add up all the ones between 10 and 39. Put it over the total. Right? If you guys can remember this right here, probability is what you want over the total. Super duper important. Questions? All right, last bit you guys don't have. Just take a picture of this. About the problems, I want to talk to you guys about some words. We've talked about this before. You are going to see questions. Some of them will say with replacement. Some of them will say without replacement. Why is that important to pay attention to? A lot of times when you have these problems, you're going to draw you want to draw a marble, and then you're going to draw another one. Excuse me, another one. If there is replacement, that means there's 10 marbles in a bag. I put my hand in, I take it out, I look at the marble, I put it back in. How many are left when I go to pull out again? 10. That's with replacement. If it says without replacement, that means I reach into my bag of 10 marbles, I pull it out, I look at one, I put it over here. How many are left for me to pull from? How many guys? Guys at home?
9.
Thank you, Richard. That is very important because the denominator changes. That means your numbers are going to change. Now remember too, another thing that you really have to pay close attention to. The word and means to do what? Multiply. The word or means to do what? Add. So if I look at this first question, number 1 has two questions. The first one asks you what? And. The second one asks you what? Or. So in the first answer you get, you're going to multiply the two fractions together. In the second one, what are you going to do? Add them. Really important that you pay attention to that. Another thing that's super important, what do they tell you about these marbles? When you take them out and you look at them. Do you put them back in or no? No. So watch. This is how you do this. There's 8 marbles in a bag. Remind me again what probability is. It's want over total, right? 8 marbles in a bag. 4 are red, 2 are green, 1 are yellow, 1's black. Without replacement. So I want the probability of me putting my hand in the bag and I get out a red. How many red marbles are there?
3.
What does that number say right there? 4. Out of how many total are in the bag? 8. Okay. Now the word and. When I see and, what does that mean to do? Multiply. So what's the second kind of marble I want to get? Yellow. How many yellows are there? 1. Out of now, guys, since there was not replacement, how many marbles are left for me to choose from? I start off with 8. I reached my hand in, I looked at it, I put it over there. How many are left in the bag? 7. I'd multiply this together. 4 times 1 is 4 over 8 times 7 is 56, right? So what's my answer? What's the probability of me getting a red and a yellow? 1 out of 14. All right. Second question. Same thing. I do not put the marble back. What does that mean about my denominator? It decreases by 1, correct? So it's the probability of a black. So it's want over total. How many total marbles are there? 8. How many of them are black? Okay. What does the word or mean to do? Add. Now, I took the marble out. I looked at it. I threw it at Miss Carver. How many are left? 7. Thank you. And of those 7, how many are red?
4.
So do I just add this together and I get 5 over 15? No, I have to get a what? What's the common denominator between 8 and 7? Okay, 56. So I have to say, all right, well, 8 times 7 gives me 56. So 1 times 7 is 7. 7 times 8 is 56. So 4 times 8 is 32. What's 32 plus 7? 39 out of how many? 56. That's it. You guys just got to pay attention to the words. How many marbles, excuse me, total are in the bag? How many? 8. Thank you. 8 marbles total. What does this say right here? So I'm going to take my marble out, look at it, and then I'm not going to throw and hit Miss Carver. I'm going to put it back in the bag. So how many marbles are in the bag the second time I stick my hand in there? Same amount, 8. So probability of 1 red. How many reds are there to begin with? How many reds are there to begin with? 4. Out of how many total? 8. Thank you. What does the word and mean to do? So multiply. So times. I put that marble back in, so there's still 8 in the bag. And how many of them are now green? 2. Multiply that together. 4 times 2 is 8. 8 times 8 is 64.
Oh.
Simplify that, please. What is it? Yep, 1 out of 8. Good. All right, second time. With replacement, it means I put it back in. So how many are green? I want a green or a red. How many are green? 2 out of 8. What does the word or mean to do? Thank you. How many are red?
4.
Do they have the same denominator?
Yeah.
So I just say 4 plus 2 is 6, and I simplify that, and I get 3 over 4. So a big thing for you guys to read, with or without replacement. Okay, denominator changes without replacement. Stays the same with. Another thing is and or or. And means to multiply, or means to add. Overlapping and mutually exclusive, right? Let's look at that for a second. I'll upload this in just a minute. Okay, this is a good visual for mutually exclusive and overlapping. What if I said to you guys the probability of getting a black card or a face card? Watch. Here's all the black cards. How many of them are black? It's half the deck, guys. What's half of 52?
26.
Okay, thank you. So 26 out of the 52 are black. Agreed? And then I said, or a face card. Well, here's the face cards. What kind of an event is this if I wanted black or a face card? Is it overlapping or is it mutually exclusive? Is there an area that you colored over, or are they completely opposite of each other? There's something mutual. So in this case, for the black, you'd have 26 out of 52 plus 12 out of 52. But then you'd have to subtract the stuff that overlaps. Do you guys understand that? This is the part that overlaps right here. So if I said to you, what is the probability of a black or a face card? You guys would tell me, well, this is overlapping. Because, why is it overlapping? There's 26 cards that are black out of the 52, right? Plus, there's 12 face cards that are faces. There's 12 cards that are faces. But how many of those black cards also have faces on them? You'd have to subtract the 6 out of 52 that overlap. Do you guys see that? You subtract the overlapping part. Questions at home? Do you guys see that?
I have a question.
Yes. That's a good question. Since it's, excuse me, hold on.
End, you know how you're
Since it's
subtracting?
overlapping, you subtract the overlapping part always.
So, but for the other one, we had an or, we didn't do that. So
I'll show you one right now.
with the
I'll show you one right now. What about if I said, what's the probability of getting a 2 or a face card? Are those two things mutually exclusive, or are they overlapping? Probability of a 2 or probability of a face card. Are there any 2s in the deck that are also face cards? No. So you would say 4 out of 52 are 2s plus 12 out of 52 are face cards, right? Do you see that?
Yeah, I see that.
You only subtract what overlaps. It might be very helpful for some of you to have this on your paper and actually color like I did. When you subtract is when you have two regions that are overlapping. You subtract the, excuse me, excuse me, you subtract the overlapping part. Maybe that will be a little more helpful, but I'll put that on Canvas so you guys have that at your disposal. And then I'll publish the video right now. But I added this on the video.